Hello, my dear international student. We are going to study the classify นะครับ of the following structure as the statically determinate or statically indeterminate or unstable. Okay, we will start by classifying this kind of structure, and then if we find that the structure is indeterminate, we supposed to compute the degree of the indeterminacy of the structure. Okay, we start by the concept that we should have to classify the structure. The main concept is each structure will support by certain supports. For example, this beam support by the pin and roller, and each support if the structure is subjected to force or forces, the support will produce the reaction, and then we will find how many reaction the structure have. For this one, we have 1, 2, 3, 4. That's for the pin, and for this one, we have this one for 5. And then the R, following this, the R can consider as the unknown. Okay, it's unknown, mostly is unknown reaction. Okay, and sometimes they may also is the internal forces or moment. Okay, and then we compare with what? We compare with the equation of equilibrium. Equation of equilibrium. Equilibrium. Okay, and as you may recall from the static, most of the structure that we consider before, the R is equal to the equation of equilibrium, and each of the free body diagram usually is have 3 equation of equilibrium, in which summation f sub x equal to 0, summation f sub y equal to 0, and summation moment equal to 0. And if you have more free body diagram such as n, so all the equation, this is the number of equation, will be 3 times the number of free body diagram. Okay, if the structure has equal R and 3n, the structure will be statically determinate. If the structure has R, the unknown, larger than the number of equation of equilibrium, the structure will be statically determinate. And if the R less than Tn, the structure gonna be unstable. Anyway, the unstable also can separate into 2 conditions. Okay, one, if the force is the reaction, not the force. The one is reaction. All are parallel. That means the structure have all parallel reaction. That may be called unstable also. Or another one is have the concurrent concurrent reaction. Okay, the reaction cut at a point, so the summation of the moment is zero, making the structure unstable. Okay, by following this concept, if we come to our beam over here, for the beam over here, if we count for the unknown, we will see we have 1, 2, 3, 4, and 5. So the R gonna equal to 5. How about the number of equation of equilibrium? We have only one free body diagram, so it's 3 times 1, so it's going to be 3. This structure didn't have reaction parallel or parallel reaction or concurrent reaction, so this beam is going to be stable. Okay, and since R is larger than 3n, and it's going to be statically indeterminate. Okay, and beam, BEAM. Okay, and it's gonna have the degree of indeterminacy equal to 5 minus 3. That is going to be 2. And in short, you may write this structure as the stable plus indeterminate to second degree. That's going to have the same meaning, okay, for this beam. And next, we come to this structure. This structure is supported by 4 cables. Okay, under the applied force, the structure gonna resist by the reaction in the cable 1, 2, 3, and 4. Okay, since the force in the cable only can produce along its line of cable, so we're gonna have the reaction 4 of them like this. And you consider this, we're going to have R equal to 4. Okay, and then the 3n over here is going to be 3 times 1. Even though we have the R larger than 3n, but the reaction all parallel, so this structure can be classified as unstable even though R is larger than Tn. Unstable because the reaction is parallel. Okay, by parallel reaction, if the structure subjected to the horizontal force, you may see that by doing this, the summation of x sub x won't be equal to 0. So the structure gonna move to the right. And next, we come to the beam. Our beam is simple one now. And what we have under the application of the force, okay, the roller will have one reaction, and the pin gonna have 2 reaction. For this beam, we have R equal to 1, 2, and 3. And then the 3n, we have what? 3 times 1 is 3. That is 3n equal to 3 times 1. So the R is equal to n. The structure is going to be stable. Stable with what? Stable with statically determinate, and then beam. Okay. Okay, next we consider the frame. Now our frame have the support pin here, so it's gonna have the force reaction like this if this structure subjected to the action force here, and also the structure has the pin here, so there is two more reaction. Since the structure is connected by the hinge, okay, that means this structure must be separate to two portion, the yellow and the green. Okay, by doing this, what we have the R, the whole number of R. The R is going to be 1, 2, 3, 4. Okay, the reaction is 3. But for this problem, the hinge can produce two more internal forces. So the unknown is going to be 3 plus 2. Okay. Sorry, 4 plus 2, not 3. 1, 2, 3, 4. This is going to be 4 plus 2. The total is going to be 6. And the 3n, 3 equation for one free body diagram. Since we have 2 free body diagram, the known equation going to be 6. Okay, so this frame gonna be stable. And stable with what? Stable with statically determinate, since R is equal to 3n. So it's gonna be statically determinate frame. Okay. The last problem that we have is this picture. Okay. This beam has the roller. Under the application of the force, the roller will produce the reaction. However, the reaction, all of them are intersect at the point O. Okay, so R is 3, and then the 3n is going to be 3 times 1 is going to be 3. Although they are equal, but this structure is going to classify as the unstable. Unstable due to what? Due to the concurrent reaction. Okay, reactions at O, in which summation moment above O won't be 0. If you take here the force P times D, not going to be 0. Okay, so this is the unstable beam. Okay, next let's consider the second page that you may have. Same thing, they're asking you to classify the frame to be statically determinate or statically indeterminate, and if possible, don't forget about the unstable. Okay, and if it's indeterminate, they require us to find the degree of indeterminacy. Okay, and all internal choices are fixed for these two problems. Okay, and the author, they're going to specify it. Okay, come into this again, we need to consider the unknown. Okay, let us talking about the unknown. Unknown can be reaction. Okay, and also unknown can be internal forces. It can be normal force, the shear force, and also the moment. Okay, this is especially for the frame. And then since the frame connect by the beam, so we need to cut the frame into two pieces for this one because the column connect by the beam. And then we just draw the free body diagram. What do we have? Okay, under the action of the force, for example, like this, what may have is the support over here is fixed. Okay, when it's fixed, this one gonna have this one, this two, and the moment. And this one is the pin. Okay, the reaction here can be two forces. Okay, not only this, due to the beam, each section of the beam you cut will have three more unknown, and due to the third law of Newton, these three unknown forces are equal but in the opposite direction. So one internal cut will produce only three unknown. Okay, and you may get all the internal forces and moments like this. So based on this, what you will have to find the unknown. The unknown can be 1, 2, 3, and 1, 2 plus 3. Sorry, it's 2. That is the total number of the reaction. And then you also have the internal forces and moment. So it's going to be 3 plus 3. So now the total is 5 plus 6 is 11. This is for the unknown. How about the equation of equilibrium? You got to have 3 for each free body diagram. Since you have two portions of the frame, so it's 3 times 2 is going to be 6. Okay, your structure is going to be stable. Okay, and it has the unknown larger than the equation of equilibrium. So this is statically indeterminate frame. Okay, and what is the degree of indeterminacy? The degree with degree of indeterminacy equal to 11 minus 6. That is going to be 5. Okay, and if you like to make in short, this is going to be indeterminate frame with what? With 5 degree of indeterminacy. You may like it like this if you like. Okay, and by the same concept, coming to the second frame over here, this frame have 3 line of column. When it has 3 line of column, that means you're going to cut like this. Okay, by doing this, coming back to consider the support. This is the pin, the unknown going to be 2. This is the fix, the unknown going to be 3. And this is going to be the pin, the unknown going to be 2. And then it cuts going to have 3 unknown forces and 1 moment. Okay, so the total you have is going to be 2 plus 3 plus 2. That is for the reaction. Okay, and you have what? Plus what? Plus 3. And then it's going to have 1, 2, 3, 4, 5, 6, 7, 8. 3 times 8. So the total R of this is going to be, this is going to be 7 plus 24. Is total going to be 31. And the structure, each portion of the free body diagram gonna have 3 equations of equilibrium. So the total equation of equilibrium will be 3 times 3 is going to be 9. Okay, for this structure is going to be stable. Stable with what? With statically indeterminate frame. Okay, and the degree of Determinacy equal to, this is 31. Okay, and then it's going to be minus 9, and then you get this is 22 degree of indeterminacy. Okay, this is one of the problem that's important to us to determine the indeterminacy of the frame. We have 3 more. Okay, let us consider this. The previous 2 frame, that is, it has internal joints that are fixed connected. The other 3, the joints may be not. Consider this structure. This structure have the locker. Locker is the same as the roller. Okay, and this is the pin. Support by these 2 support, and then the structure has the fixed connection here and the pin connection here. When it's the pin connection, that means you can separate this structure into 2 portions like this. Okay, and if you check, the unknown gonna include both reaction and internal forces. This is going to be 1, since this is pin, 1, 2, and since this is the pin is the same thing as the hinge. Okay, NGE is going to produce 2 more. So the R of this frame is going to be 3, and plus 2 is going to be 5. And the structure, each part of it gonna have 3 equation of equilibrium, and then there is 2 free body diagram. So the total equation gonna be 3 times 2 is 6. Okay, and now you can see that this problem, the unknown, is less than the equation. So this frame gonna be the unstable frame. Okay. Next we have the beam. The beam have the supports of roller and fixed. Okay, this gonna be produce 1, 2, and 3. And then our beam can be separated into 3 different portions because the beam connect by the pin as shown. By connecting with the pin, again, this is going to produce 2 unknown and 2 unknown. So the R going to be what? Going to be 2 plus 2 is the 4. And then the reaction going to be 3, 4, 5 and going to be 5. The total unknown going to be 9. And then each free body diagram have 3 equations. So the total number of equation of equilibrium going to be 3 times 3 is going to be 9. Since the unknown is equal to the equation of equilibrium, so this structure gonna be stable plus statically determinate and beam. Okay, we coming to our last problem. Is the frame this time, and this time the frame is fixed, so the unknown gonna be 3, and the joist here is fixed, so we can consider this beam and column as the same free body diagram. And since it's connected by the pin here, we have this for the second problem. And since this is the pin, this is going to produce 2 more unknown. So the R is going to be 3 plus 3 and then plus 2. The total is going to be 8 unknowns. For the equation of equilibrium, 3 times number of free body diagram is going to be 3 times 2 is going to be 6. Okay, this frame going to be stable for sure, and it's going to be statically indeterminate frame with how many? With 8 with 2 degree of indeterminacy. Okay, this is our example. How do we check the determinacy and stability of the beam and the frame? The concept is simple. We compare the unknown with the number of equation of equilibrium. The unknown can be the reaction and the internal forces, like for this example. And the number of equation of equilibrium is the 3 equation for each free body diagram. If you have n free body diagram, you just times 3 with the n. You get the number of equation of equilibrium. If the unknown is larger than the equation of equilibrium, the structure is statically indeterminate. And then you got to check the number of degree of indeterminacy. Just R minus n. You get 2 degrees. Okay. And if the unknown is equal to the number of equation, your structure going to be statically determinate. If the R is less than Tn, the unknown less than the number of equation, the structure is unstable. And we should know that unstable structure also come from the concurrent reactions and also the parallel reactions. Okay, student, I hope you have a chance to study everything in more detail, And I also suggest you guys do a lot of homework and exercise in order to produce more skill on this kind of analysis. And I hope you enjoy this clip. Okay, see you later.